Hey, what's up everyone, Sean here, and welcome to another new video with a bunch of random facts. Now, in this one I'm going to be going through the area that I was watching a movie called The Imitation Game, which is featuring Benedict Cumberbatch. And it's a really great movie overall, but there's a machine in it called the Enigma Machine, and I thought it would be a very, very cool and interesting video to actually look up facts about the actual machine, for what it was actually used for, and just a bunch of fun facts about it. So without further ado, let's go into it. But before I begin everything, as a preface, so again, I always pull these facts for sourcing and for accuracy from Google. And then if I cannot pronounce a word, or I don't know how to say it or pronounce it, then I will just spell it out for you guys as slowly as I can, and just give the best kind of context for it as well. And then, as always, some of these facts, or many of them, might be common knowledge for some of you. But again, the whole point of these videos, as always, is to learn new things, whether it's just one or two per video. That's always the hope and the goal for why I make them. But without further ado, yet again, let's go ahead and get into a bunch of fun facts about the Enigma Machine. Alright, the Enigma Machine was an electromechanical cipher device used to encrypt and decrypt messages. It was invented by German engineer Arthur Scherbius. Scherbius patented the Enigma concept in 1918. The machine was originally intended for commercial use before military adoption. Germany's military became Enigma's most famous user during World War II. Every key press encrypted a letter differently based on the machine's current settings. Pressing a key also caused one or more rotors to rotate. The rotating rotors made the cipher change continuously during a message. An Enigma keyboard resembled that of a typewriter. Instead of printing letters, the machine illuminated a lamp to display the encrypted character. The machine required electrical power from an internal battery. Most military Enigma machines contain 3 rotors, although later versions use 4. Each rotor contained complex internal wiring that substituted one letter for another. Rotors could be placed in different orders before encryption began. Each rotor could be rotated to one of 26 starting positions. The alphabet used by Enigma contained only the 26 uppercase letters. The machine did not include numbers or punctuation. Operators often spelled out numbers as words within messages. A reflector inside the machine sent the electrical signal back through the rotors. Because of the reflector, encryption and decryption used the same machine settings. A letter could never encrypt to itself. The reflector prevented the machine from producing the same input and output letter. Many military Enigma machines included a plug board on the front. The plug board swapped pairs of letters before and after the rotor encryption process. The plug board dramatically increased the number of possible encryption settings. The plug board was known in German as Steckerbrett. 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 Up to 10 pairs of letters were commonly connected on the plug board. Unplugged letters remained unchanged by the plug board. The rightmost rotor advanced with every key press. Rotor stepping created a constantly changing encryption pattern. The middle rotor advanced less frequently than the right rotor. The left rotor moved only occasionally during normal operation. The Enigma machine featured a mechanical double-stepping behavior that affected rotor movements. The double-stepping feature was originally an unintended consequence of the design. Rotor notches determined when the next rotor advanced. Different rotors had their notches in different positions. Excuse me. Early military Enigma models offered operators a choice of several interchangeable rotors. Only a subset of the available rotors was installed for any given day's operation. The order of the rotors was part of the daily encryption key. Rotor ring settings could also be adjusted independently of the starting positions. Ring settings changed the relationship between the rotor wiring and its turnover notch. Daily key sheets instructed operators how to configure their machines. Operators were required to change Enigma settings regularly, often every day. The same settings had to be used by both the sender and receiver. An incorrect rotor order made successful decryption impossible. Even one incorrect plug board connection would produce unreadable text. Operators usually encrypted messages in groups of 5 letters. 5-letter groups made messages easier to transmit and copy accurately. Spaces between words were normally omitted in encrypted messages. Message recipients restored word breaks and punctuation after decryption. Each encrypted message began with a specific message key. The message key was typically encrypted before being transmitted. Operators followed strict procedures to avoid using predictable settings. Mistakes by operators sometimes weakened Enigma security. Repeating message patterns occasionally helped allied crypt analysts. Allied crypt analysts, my bad. Weather reports often contained predictable phrases useful for code breakers. Standard military greetings also created recognizable patterns. The German Army and Air Force used different Enigma key networks. The German Navy employed more complex Enigma procedures than the Army. Naval Enigma was considered the most difficult version to break. Some Naval Enigma machines used 4 rotors instead of 3. The 4th rotor in Naval Enigma was thinner than the standard rotors. The 4-rotor version is often called the M4, so M as in Mary 4 Enigma. German U-boats relied heavily on Enigma for secure communications. Enigma messages were commonly transmitted using Morse code over radio. Radio operators manually sent the encrypted text letter by letter. Anyone with a radio receiver could intercept Enigma transmissions. Encryption prevented intercepted messages from being immediately understood. Breaking Enigma required determining the machine's daily settings. There were millions of possible basic rotor arrangements before considering plugboard settings. Including plugboard connections increased the number of possible configurations enormously. The total number of possible Enigma settings is often estimated to exceed 100 quintillion for common military configurations. The machine's security depended on both its mechanical design and its disciplined operating procedures. Enigma was regarded by Germany as virtually unbreakable during much of World War II. Despite its complexity, Enigma was ultimately defeated through a combination of mathematics, engineering, intelligence gathering, and operator mistakes. The first major breakthrough against Enigma were made by Polish crypt analysts, I can't say that word, in the early 1930s. Marian Rejewski used mathematical techniques to reconstruct the Enigma's wiring. These are names, I can't pronounce them right, but Jerzy Rosycki helped develop methods for solving Enigma traffic. Henryk Zygalski created perforated sheets used to identify machine settings. In 1939, Polish cryptanalysts shared their Enigma research with British and French intelligence. Britain established a major code-breaking center at Bletchley Park. Thousands of people worked at Bletchley Park during World War II. Many codebreakers at Bletchley Park were mathematicians, linguists, engineers, and chess players. Alan Turing, from the movie, played a leading role in improving Enigma breaking methods. Turing helped design an electromechanical machine known as the bombe, B-O-M-B-E. The bombe rapidly tested possible Enigma settings. The bombe did not decrypt messages directly. It eliminated impossible settings. Once likely settings were found, analysts completed the decryption process. Gordon Welchman introduced an important improvement called the diagonal board to the bombe. Welchman's enhancement greatly increased the bombe's efficiency. Captured Enigma machines provided valuable information to Allied codebreakers. Captured codebreakers were often just as valuable as the machines themselves. Allied naval operations occasionally focused on capturing German cryptographic materials intact. Weather ships were among the targets because they often carried Enigma documents. German submarines sometimes sank before their cryptographic materials could be destroyed. Recovering rotor settings from captured documents could provide weeks of intelligence. Intelligence obtained from decrypted Enigma traffic was given the codename Ultra. Ultra intelligence remained one of the Allies' most closely guarded secrets. Many military commanders received Ultra intelligence without knowing its true source. The success of Enigma codebreaking remained classified for many years after World War II. It's frozen here a little bit. There we go. Many historians believe breaking Enigma shortened World War II in Europe. The exact amount of time saved by Enigma code breaking is still debated. The German military never realized the full extent of the Allies' success against Enigma. German commanders often trust Enigma communications completely. Different branches of the German military operated separate Enigma key networks. Some Enigma networks change keys every 24 hours. Certain high security networks change settings even more frequently. Every rotor had 26 electrical contacts on each side. The internal wiring of each rotor remained fixed once manufactured. Rotors could be identified by Roman numerals such as 1, 2, 3, 4, and 5, or 1, 2, 3, IV, and V. Later, military Enigma systems introduced additional rotor choices. The reflector was removable on some Enigma models. Different reflector versions were designated with letters such as B and C. Some later reflectors allowed limited rewiring for increased security. The Enigma lamp board contained one light for every letter of the alphabet. Pressing a key completed an electrical circuit through the machine. Electricity traveled through the plug board rotors, reflector back through the rotors, and finally to the lamp board. No two rotors contain the same internal wiring pattern. Rotor wiring was carefully designed to produce complex substitutions. Enigma encryption was entirely mechanical and electrical with no electronic components. The machine required regular maintenance to ensure reliable operation. Dust and wear could affect the smooth movement of the rotors. Operators were trained to set up and operate the machine accurately under strict procedures. Small setup errors could prevent the intended recipient from decrypting a message. Today, original Enigma machines are highly prized historical artifacts and collector's items. So there's a bunch of random facts about the Enigma machines. I hope you guys learned something or enjoyed that quite a bit. If you did, give me a big thumbs up on the video. And as always, for more fun facts and random knowledge about everything, definitely subscribe for more videos if you enjoy it. Thanks for watching as always, and I will see you all in the next one.